Thank you very much for your patience. We'll now begin the 4th Nuclear Supply Chain Symposium. I am Yoshida from Japan and US Corporation, and I'll be serving as the moderator for today's event. Thank you for your cooperation. To begin, representing the organizers, we'll have the opening remarks from Mr. Takuro Komori, a Parliamentary Vice Minister of Economy, Trade and Industry. I am Takuro Komori, Parliamentary Vice Minister of Economy, Trade and Industry. Thank you very much for joining us today at the 4th Nuclear Power Supply Chain Symposium. I would also like to express my sincere gratitude for your ongoing exceptional efforts in ensuring stable supply of energy. And March 11th, the day after tomorrow, marks the 15th anniversary of the Great East Japan earthquake. And never forgetting the experiences, reflections, and lessons learned from the accident at the Tokyo Electric Power Company's Fukushima Daiichi Nuclear Power Station is fundamental to our energy policy. The misconduct uncovered at Chuba Electric Power's Hamaoka Nuclear Power Station at this crucial juncture is an unacceptable act that severely damages public trust. We take this matter extremely seriously. METI, the ministry, is demanding a thorough investigation into the causes and the development and implementation of effective measures to prevent recurrence. And now, when we need a nuclear power, the need is increasing, so it's crucial to build public trust steadily by continuously improving safety based on the reflections and lessons learned from Fukushima. We strongly urge all industry stakeholders to continue pursuing safety as a united industry. So let me talk about trends surrounding nuclear power. The domestic and international environment surrounding energy policy has been changing dynamically in recent years. With electricity demand expected to grow due to the use of AI and data centers, we must ensure that energy supply does not become a constraint on Japan's economic growth. Furthermore, the perspective of energy security is also important due to heightened geopolitical risks. Reflecting these environmental changes, global demand for nuclear power is increasing. In Japan, too, it is essential to maximize the use of power sources that contribute to energy security and have high decarbonization effects, such as nuclear power. As outlined in the last year's 7th Basic Energy Plan, to maximize the use of nuclear power, we will proceed with restarting existing nuclear power plants and rebuilding them into next-generation innovative reactors while ensuring safety and securing local understanding as fundamental prerequisites. The Japanese growth strategy announced by the Takaichi cabinet also positions GX and fusion energy as strategic fields. We will work to attract further active investment from both the public and private sectors, including increased capital investment in research and development. Regarding domestic nuclear power development, Unit 6 of Kashiwazaki Kariya Nuclear Power Plant resumed operation in February this year after a 14-year hiatus. Late last year, Hokkaido Governor Suzuki expressed his consent regarding the restart of Unit 3 at the Tomari Nuclear Power Plant. And Kansai Electric Power Company has resumed voluntary on-site surveys at the Mihama Nuclear Power Plant to explore the installation of successor reactors, marking significant progress. We express our respect for the efforts of everyone supporting the nuclear industry, including local residents. Furthermore, for the long-term utilization of nuclear power, addressing the back end is crucial. Amending the final disposition of high-level radioactive waste is a national challenge that cannot be deferred to future generations. On March 3rd, the Minister of Economy, Trade and Industry, Mr. Kazawa, submitted a request to conduct a document survey on Rishima Island, Ogasawara Village. As a nation, will provide thorough explanations to the residents of Ogasawara Village. Let me talk about nuclear industry infrastructure. To maximize the utilization of nuclear power, the supply chain and human resources infrastructure are indispensable elements for advancing the full utilization of the existing reactors and development and deployment of next-generation reactors. This foundation has been threatened by the loss of business opportunities following the earthquake. Recognizing this crisis, the national government launched the Nuclear Power Supply Chain Platform and has been implementing various measures and support for developing equipment and components, and for training and securing nuclear personnel to build the supply chain is one thing, and dispatching public-private missions in supporting the acquisition of overseas certification to facilitate participation in overseas construction projects and other initiatives providing support to various nuclear-related companies. And through this platform, we'll continue to listen to your needs while working as a nation to maintain and strengthen the nuclear industry and its human resource base. As a nation, for those involved in the nuclear industry and to the young people who will shape tomorrow, we are deepening discussions on the future outlook for nuclear power generation and the creation of a cross-sectoral command center involving industry, government, and academia to comprehensively drive nuclear human resource development. The strength of industry community is indispensable in charting the future of nuclear power generation, so we sincerely hope the industry and the nation to unite and work together. As a nation, we remain fully committed to advancing our nuclear energy policy. I sincerely wish all of you gathered here today continued success and achievement. This concludes my remarks. Thank you very much.
Thank you very much, Mr. Komori. We would now like to move on to the keynote address. We were expecting the Commissioner of the Agency for Natural Resources and Energy, Mr. Murase, but he has some urgent business that prevented him from joining us today. But kindly, Mr. Kume, the Director General of the Electricity and Gas Industry Department, has agreed to step in Mr. Murase's place. Thank you very much, Mr. Kume. Good afternoon, and thank you very much for the kind introduction. My name is Takashi Kume, the Director General of the Energy and Gas Industry Department of the Agency of Natural Resources and Energy. We apologize for the fact that our Commissioner was not able to address you here in person. Given the current circumstances, it has proven difficult for him to leave his office. So I'd like to start with the energy challenge for Japan. And so it is probably the most salient. And since the oil crisis, we as a country are very vulnerable. And there is this risk associated with fossil fuel that was reminded during the Russian aggression against Ukraine. And given what's happening now in the Strait of Hormuz and the situation in Iran, it is all the more important and relevant. And so the seventh Strategic Energy Plan talks about the energy self-sufficiency, the dependency on fossil electricity, etc., and states that the stable supply of energy is the number one challenge. And so we will need to really work hard and full scale on this. And this looks at the electricity demand outlook. And it's probably common across the world. Data centers and semiconductors will drive the increase in demand for electricity. And against that backdrop, there is a rising need to for stable and decarbonized electricity, and that will have a great impact on the Japanese industrial competitiveness. And that is the backdrop against which we came up with the 7th Strategic Energy Plan. And various countries are moving to leverage nuclear energy. Particularly last year, there were a number of developments in Sweden or in Belgium or in Switzerland. Those countries have decided to proactively increase nuclear energy. Some of them have really changed their policies. Canada has approved the construction of the first SMR. And in Asia, if you look at countries such as Indonesia, Philippines, and Malaysia, they are looking more seriously about the possibility of using nuclear energy as an option. And international financial institutions are also making the move. World Bank, ADP, Asian Development Banks are also lifting their previous bans on funding nuclear energy programs. Now, IEA has published its World Energy Outlook 2025, which provides the future outlook of the energy system. And they talk about the shift in the center of gravity, renewable energy, more important, etc. And it also talks about the nuclear energy comeback. So against that backdrop, the 7th Strategic Energy Plan talks about the importance of renewable energy, using that as a source for energy stable supply and decarbonization, but also seek a balanced and diversified mix to avoid overdependence on a particular type of electricity or fuel. And it also talks about the leveraging of renewables and nuclear energy, which both contribute to energy security and effective decarbonization. And so with regard to the restart of the nuclear power stations, obviously safety comes first and foremost. At the same time, there's another focus on next generation innovative reactors, provided that certain conditions are met. And that's also explicitly stated in this 7th Strategic Energy Plan. And in doing so, it is also important to look at the broader nuclear industry and the human resources pool. And I'm sure all of you here are well aware of this. Japan was proud of the high domestic procurement rate and the contribution to the jobs and economy. We would obviously need to maintain that. But for the first time, for those initiatives to really start full scale, we will need to make sure that the skill set, etc., are maintained. And so this is really a challenge that the government should take seriously. But then the government alone cannot do anything. So we need to work together with industry as well as academia. And this shows the energy supply demand outlook. So in FY 2023, 8.5% of the energy demand was met by nuclear. And then in 2014, obviously, it depends on how others will grow, but we expect nuclear to be responsible for about 20%. Now, this looks at how the current nuclear power stations are doing. Kashiwazaki Kariwa has successfully restarted. So there are 15 units that have successfully restarted, but some are still, some have some installation license change approved, but some are still under review, and many have yet to even file for that. But if you look at the outlook of the nuclear power and the supply capacity, to realize 20% in 2040, we will need to work on capacity utilization improvement and addition of next generation innovation. So it's not just restarts that we can work on. There are other things we need to do. And so given that there's a long lead time, like over 10 years or 20 years to build those new nuclear power stations or units, this is really something we need to act on now. And so we'll need to look at the restarts, long-term operation, and enhanced capacity factors. Those would be the focus. At the same time, we will need to think about the next generation of reactors, the power reactors, that is. And so, as you can see, there are a number of next generation technologies that are being proposed and developed. I won't go into too much detail, but particularly the innovative light water reactors, or globally SMRs. Those are the very important ideas that we need to put to practice as soon as possible. And with regards to the future for nuclear energy, we have a subcommittee of the Advisory Committee for Natural Resources and Energy for the agency, and we are actually discussing all this. Obviously, the industry members and members from the academia, local governments are also focused and engaged in this. This will be a very important discussion on the installed capacity, etc. There are obviously some uncertainties, but we are looking at what the right picture should be in the future that we will seek to realize. Now, one of the things that government should do is to make sure that there's a right business environment, particularly with regard to financing. So there are risks that the private sector financial institutions cannot necessarily shoulder. And so public measures such as government credit enhancement, etc., are being mulled. And if legislation is necessary, we will work on that as well. With regard to supply chain enhancement, and I maybe sound repetitive, but if you think about the long term, you need to make sure that there's a right supply chain and human resources pool. In March 2023, we established this NSCP, Nuclear Supply Chain Platform, to look at nuclear human resources development and parts obsolescence, addressing that issue, and also trying to support Japanese suppliers being part of international project. And there are a large number of companies and entities that joined. I'm sure many of you here are members of this platform. I'd like to thank you for your efforts, and I'd like to say that METI is also committed to supporting these efforts. And specifically, for example, for the suppliers, we would like to support your technology development, and we also are looking at your infrastructure. So we are actually increasing the budget. We are using the so-called GX bonds or climate transition bonds to fund those activities. And we are also focusing on commercial grade dedication and 3D printers, as well as utilization of AI, so as to leverage all those new technologies, and we want that to be an industry-wide initiative. We are also supporting that as the government. So we are supporting each and every entity with some of the projects, but we are also trying to support a wider, broader, common initiatives. And when you think about the supply chain, obviously human resources is a very important part. And if you look at the whole of Japan, and if you look at the manufacturing industry as a whole in Japan, we are facing a serious shortage. And against that backdrop, how do you make sure that there are enough people to be in the field and in the plants? So we are working with trying to engaging students as well as mid-career people. We are getting the support of some of the supplier companies to offer those courses to those potential new nuclear workers. And it's not just METI. We are also working with MEXT, NRA, all those related agencies. We're also working with JAIF, so that's an industry organization. But sometimes there could be some overlaps, or there could be some spots in between that we are missing out on. So we are trying to coordinate across those different efforts. Given that we need to really make sure there's the right human resources pool in Japan, we would like to do this effort more effectively and efficiently, and therefore coordination is all the more important. So given that understanding, METI actually took the lead to organize this new consortium and or council. So this is a Council for Nuclear Human Resource Development and Enhancement. So this is intended to become footprint to establish a command center to coordinate various activities at various agencies and organizations. And given that there's a wave of nuclear building in the global industry, we are trying to make sure that the Japanese industry can leverage that opportunity. So the Japanese suppliers, so that they can be part of the construction abroad, we are actually helping. For example, we sent a mission or a group of suppliers to appeal the track record and the strength that the Japanese suppliers have. We are also organizing study sessions for the international and or overseas standards and codes that those suppliers need to address, so that Japanese suppliers can contribute to energy security outside of Japan as well, and also get the right opportunities so that they can maintain their technology base and human resources base. So given the global situation that we are in, we will really need to think about the maximal use of nuclear energy in Japan. And for that to be sustainable, we will need to make sure that the supply chain is there, and we would really need the industry support and cooperation to make this happen. In addition, for the next generation innovative reactions, we will need to make sure that there is the right parts and components material supply system, and actually enhance that in conjunction with human resources. So we would continue to work on these so as to proceed with the policies of the government as a ministry, and we hope we can continue to have the support of the Japanese industry. Thank you very much for that.
Thank you, Mr. Kume. We now start session 1, the future of the nuclear industry. There'll be 3 presentations. First is Mr. Shunichi Kito, Committee Chair of Energy and Resources of Keidanren, Japan Business Federation, and Representative Director and Chairman of Idemitsu Kosan. He will speak under the title Business Community's Viewpoint on Energy Policy. Mr. Kito, please. Thank you. I am Kito from Idemitsu Kosan. I'm Vice Chairman of the Board of Councilors at Keidanren, and also Committee Chair of the Energy and Resources. First, I'd like to extend my heartfelt congratulations in the opening of the Nuclear Supply Chain Symposium. From business community's viewpoint, I'd like to take this opportunity to share with you what expectations we have within the business community on energy policy, especially nuclear power. You can see the slides on the screen. In December of 2024, Keidanren compiled Future Design 2040, outlining the direction Japan's economy and society should take. Japan faces 2 structural challenges, namely declining birth rates and aging population, and being a resource-scarce island nation. To overcome these constraints and achieve sustainable growth, we have to set out our goal of becoming a science and technology-oriented nation and a trade and investment-oriented nation. To achieve this, sustaining a virtuous cycle of growth and distribution is essential. stable, and affordable energy supply is a fundamental prerequisite for this. Without this, we cannot strengthen industrial competitiveness or foster innovation or realize a richer life for our people. Meanwhile, the energy situation has become increasingly uncertain in recent years. Most recently, this Israeli-U.S. attack on Iran on February 28th, which has further heightened tensions in the Middle East. And there is a prolonged situation in Ukraine. They all represent continuing risks to resource prices and supply networks, highlighting the importance of energy security. In Japan, drive for electrification through green transformation and the advancement of digital transformation fueled by generative artificial intelligence have radically shifted the electricity demand outlook from a declining trend to a significant expansion. Achieving carbon neutrality by 2050 while adhering to S+3E principle, that is, achieving both decarbonization and an affordable and stable electricity supply, has become an increasingly important policy issue for Japan in maintaining and strengthening industrial competitiveness and achieving sustainable growth. One key to resolving this is the use of nuclear. Keidanren has long urged the government to actively utilize nuclear as a quasi-domestic, stable, and decarbonized power source. As I mentioned earlier, the 7th Basic Energy Plan approved by the Cabinet in February of last year clearly commits to making maximum use of nuclear. And the business community highly appreciates it. Furthermore, we are extremely encouraged by the proactive stance of the new Takaichi administration to promote nuclear policy, including consideration of cutting-edge technologies such as fusion energy. We urge the government to continue to implement concrete measures to effectively utilize nuclear power. In doing so, it is important that the quantitative outlook and vision be provided so that operators can have predictability when making medium to long-term investment decisions. To maximize the utilization of nuclear power, we must first steadily proceed with the restart of existing plants, with safety and local understanding as the fundamental prerequisites. Starting with Takahama Units 1 and 2 in 2023, Onagawa Unit 2 restarted in 2024, the first in eastern Japan. Kashiwazaki Kariwa Unit 6 is in the process of starting commercial operation. I feel that drive for the nuclear utilization is gaining momentum throughout Japan. I hope that the government will continue to take the lead in steadily promoting the restart with safety and local understanding and consent as the fundamental prerequisite. To facilitate the restart of existing plants, Keidanren has been making policy recommendations and taking various other measures, including fostering understanding among stakeholders and checking the status on site. For example, on December 1st of last year, our chairman and vice chairman visited Kashiwazaki Kariwa plant, which supplies power from the coast of the Sea of Japan to Tokyo metropolitan area and plays a significant role. He observed safety measures of Unit 6, both hardware and administrative aspect, such as emergency response programs. And they confirmed that the entire plant, including the partner companies, is working to secure safety in multiple layers. After the visit, chairman and the leadership met with the Niigata governor, Governor Hanazumi, in his office, and conveyed the chairman's respect for the governor's decision on the restart and his gratitude to the people of Niigata, and told him that Keidanren will consider measures to contribute to the development of Niigata Prefecture. Currently, 15 plants have restarted, but that's only half of the approximately 27 units envisioned as the fiscal 2030 energy mix. We need to ensure steady restart of units whose safety has been confirmed. Furthermore, if we are to maintain a 20% nuclear share in 2050, we'll need approximately 40 reactors altogether, taking into account growing demand. But after 2040, installed capacity is expected to rapidly decline, leaving only 23 units that are operational. Given the expected increase in electricity demand due to artificial intelligence and data centers, securing a carbon-free power source requires not only the restart of existing plants, but also the replacement and new builds of next-generation advanced reactors. For replacement and new builds, it's important that the public and private sectors share a roadmap on next-generation advanced reactors so as to promote the use of advanced LWRs and also advance the development of fast reactors and high-temperature gas-cooled reactors in parallel. Fast reactors are essential for Japan's nuclear fuel cycle. We hope to see efforts being accelerated to establish this technology. HTGR, high-temperature gas reactors, offers a wide range of applications, including heat supply and hydrogen production. Business community has a great expectation in this technology as a promising source of hydrogen, such as in hydrogen reduction steel making. These new reactor types have characteristics and safety features different from conventional LWRs. It's important that they be reflected in designing regulations. Looking further into the future, we also must advance fusion energy as the ultimate source from a medium to long-term perspective through practical research and development of human resources and industry base. We need to push this very proactively. Needless to say, nuclear power generation faces the enormous challenge of radioactive waste. To resolve this, it is essential to address back-end issues, such as establishing a fuel cycle through reprocessing spent fuel and securing final disposal sites. First and foremost, we await the completion of the reprocessing plant and MOX fabrication plant in Rokasho, Aomori Prefecture, scheduled for next fiscal year. We hope the government to take a leading role. For the maximum use of nuclear power and the development and deployment of next-generation advanced reactors, including fusion energy, we need technological development and regulatory reform, and maintenance, retention, and strengthening of the supply chain and human resource development. Nuclear industry cannot be established overnight. Supporting the safe plant operation over a long term requires retention, maintenance, and strengthening of human resources and the broad industrial base. But due to long shutdowns, there are strong concerns about weakening of supply chain in Japan and a shortage of labor. Engineers who have long driven Japan's nuclear industry are aging. We need an environment in which younger generations can feel safe and secure in joining the nuclear field, and ensure the transfer of technology, skills, and experience and expertise. It is important that the government take the lead in expanding investment and setting up regulations, and to show a long-term policy outlook to encourage companies make medium to long-term investments so as to rebuild the supply chain and human resources. Keidanren will cooperate with the government and will contribute to raising the overall level of the business community. Gathered here are many representatives from supply chain companies that support the nuclear industry. I'm hopeful that today's discussion will lead to new collaboration and actions. Thank you very much for your kind attention.
Thank you very much. Next, we want to invite Mr. Quinn Simon from Amazon Web Services to give us a presentation titled Enabling Digital Infrastructure with Decarbonized Energy. This presentation will be delivered in English, so please use the simultaneous interpretation receivers if needed. Okay, Ms. Simon, please, the floor is yours.
Good afternoon. Thank you to METI and the Japan Nuclear Industry Association for the opportunity to speak today. Amazon has been present in Japan for over 25 years. And during that time, we have built deep ties with the business community, government, and energy ecosystem. Our participation in this symposium reflects that long-standing commitment and a shared belief that Japan's energy transition is one of the most important ones of our time. Please allow me to walk you through Amazon's carbon-free energy journey, why nuclear has become a meaningful part of our strategy, and what Japan's supply chain means for the global nuclear build-out. Amazon is committed to achieving net zero carbon across our operations by 2040. As part of that journey, we matched 100% of our electricity consumption with renewable energy in 2023, 7 years ahead of schedule. Today, we have invested billions of dollars in over 700 carbon-free energy projects across 28 countries, spanning nuclear, solar, wind, and battery storage, representing over 40 gigawatts of total capacity, enough to power the equivalent of over 12.1 million homes. Bloomberg NEF recognized Amazon as one of the world's leading corporate purchasers of carbon-free energy in 2025, and the most active buyer in both Europe and the Asia Pacific. In a year when overall corporate clean energy buying fell globally, Amazon continued to invest. In Asia Pacific, we have more than 80 renewable energy projects. In Japan, we have invested in 32 projects, including solar and wind, as part of our growing carbon-free energy portfolio here in the country. The reason that we are investing in this scale is straightforward. Global energy demands are growing structurally. Electric vehicles, smart devices, AI, and digital services are reshaping how the world consumes electricity, and that trend is accelerating every day. Amazon's approach is to invest in all viable forms of carbon-free energy. Our strategy rests on 3 pillars. First, reliability, ensuring 24/7 uptime for critical services. Second, scalability, expanding capacity to meet growing demand. And third, carbon-free procurement, a commitment to more sustainable power sources. In practice, this means efficiency is at the core of our data center design, partnering with utilities to deliver carbon-free power, using machine learning tools to optimize energy use, and supporting the regional energy systems that supply digital infrastructure. Renewables and nuclear are not competing priorities. They are complementary pillars of a credible decarbonization strategy. Nuclear energy generates nearly 20% of US electricity and nearly 55% of the United States emission-free power. It's carbon-free, scalable, safe, and critically provides reliable baseload power 24 hours a day, 7 days a week, regardless of weather. For Amazon, nuclear therefore represents a response to a fundamental challenge. As our digital infrastructure continues to grow to support AI and cloud services, we need energy that is always on. Renewables are essential, but they are weather dependent. Nuclear fills that gap. That is why Amazon has entered into nuclear energy agreements, including with both existing nuclear facilities, such as Susquehanna in Pennsylvania, and next-generation small modular reactors developers. We are supporting SMR innovation through strategic agreements and capital investments, partnering with utilities and operators to procure carbon-free energy, and diversifying our carbon-free energy portfolio with nuclear as one component of a broader strategy. Nuclear's energy potential is clear, but scaling it requires a resilient supply chain. And that supply chain needs long-term demand signals to develop. As you all know here, nuclear is not a single product. It is a system. Deployment requires synchronized execution across engineering, manufacturing, construction, fuel supply, operations, and quality assurance. Any delay in a single component creates critical path failures across the entire project. 3 constraints define the challenge globally. First, nuclear is a system. Every domain must execute in coordination. Second, workforce and quality. Skilled labor, nuclear-grade quality control and quality assurance, and rigorous documentation are global constraints today. Personnel deficits drive cost inflation and schedule risks. Third is standardization and scale. Repeatable designs and predictable supply chain replace custom approaches. That's because standardization lowers unit costs, shortens lead time, and reduces uncertainty. The strategic implication is this: long-term corporate demand commitments help build the resilient global supply base that nuclear deployment requires, and Japan is a key node in that network. That brings us to Japan and why Japan matters. 3 principles define what enables resilient nuclear supply chains. The first is demand visibility enables investment. Long-term demand signals unlock supplier capacity. Bankable offtake commitments enable manufacturers to build out production lines with confidence. Second, early engagement improves outcomes. Design for manufacturer, qualification planning, and realistic lead times ultimately reduce execution risk, and supplier collaboration prevents late-stage bottlenecks. Third, and most relevant for this audience, Japan's strengths scale globally. Japan's precision manufacturing, quality culture, and heavy industry capabilities are not just assets for Japan's domestic nuclear restart program. They are critical enablers of global nuclear deployment. Our own experience illustrates this directly. In November 2025, X-Energy, our SMR development partner, signed a $40 million graphite supply agreement with Toyo Tanso for high-grade IG-1110 isotropic graphite for the XE100 reactor cores. This graphite acts as a critical neuron moderator and structural component. This partnership is a signal of what is possible when Japan's world-class manufacturing meets the global nuclear build-out. So let me share how Amazon is putting these principles into practice. Amazon participated in an X-Energy funding round to support the XE100 reactor design, an advanced gas-cooled small modular reactor with inherent safety features and flexible modular deployment. X-Energy is building a fuel fabrication facility and advancing SMR deployment towards our goal of 5 gigawatts of new nuclear capacity in the United States by 2039. In Washington State, Amazon is partnering with Energy Northwest to develop 4 XE100 SMR units with an initial capacity of 320 megawatts, enough to power the equivalent of more than 770,000 US homes, with the project expected to come online in the early 2030s. This project adds new carbon-free baseload power to the Pacific Northwest grid, benefiting not just Amazon's operations, but the communities that those grids serve. The XE100 complements our renewable energy portfolio: advanced gas-cooled design, flexible modular deployment, inherent safety features, and 24/7 carbon-free operations. Drawing on our experience across these operations and agreements, 4 lessons stand out for anyone looking to scale renewable energy, nuclear energy. The first is flexibility and creativity. First of its kind nuclear developments require commercial solutions that do not yet exist. Investing in and adapting those solutions is how the industry will move forward. The second lesson learned is the need for collaborative models. Tailored partnerships with experienced nuclear operators are critical. Amazon does not own or operate nuclear facilities. We partner with those who do. One-size-fits-all approaches are not going to work in nuclear. The third is grid integration. Our goal is to support regional energy systems that supply digital infrastructure and broader grid demand, not to optimize for a single customer's needs, but to add new carbon-free capacity to the grids that all of our communities depend on. And the fourth is the need for long-term agreements. Reducing nuclear development risk requires long-term contracts and strategic financing. Certainty of demand is what unlocks investment in supply chains, in workforce, and manufacturing capacity. These are not just lessons from US projects, they are a framework for how corporate energy demand can support Japan's nuclear goals, providing the long-term demand signals that justify supply chain investment, workforce development, and capacity expansion. Thank you very much. Amazon is genuinely committed to Japan's energy transition, and we look forward to continued dialogue with METI, the Japan Nuclear Industry Association, and the broader supply chain community represented in this room today. Thank you very much.
ありがとうございます。
Thank you very much. Before we move on to session 2, we will take a 5-minute break. Session 2 will begin at 5 minutes to the hour. That would mean 55 minutes past 1 Japan time, or 5 minutes before 2 p.m. Japan time. Thank you. Ladies and gentlemen, thank you very much for waiting. We will move on to Session 2, Initiatives for the Development and Deployment of Next-Generation Advanced Reactors. This session will be facilitated by Mr. Seiichi Miyashita, Director of the Office for Nuclear Technology and Human Resources, Nuclear Energy Policy Planning Division at the Agency for Natural Resources and Energy. Good afternoon, and thank you very much for the kind introduction. This is Seiichi Miyashita. Nice to meet you all. Without ado, I'd like to begin session 2. So we will look at initiatives for the development and deployment of next-generation advanced reactors. We will look at next-generation light water reactors. There are a number of variations in both PWRs and PWRs. We will invite the companies involved in those developments to report on where they are. When we think about the supply chain enhancement, it is indeed very important to make sure that new reactors and projects thereof make good progress. So we will hear where they all are. And when we think about the future supply chain investment and enhancement, I'm sure this will be quite informative. So I'd like to now invite the presentations in one by one. So first, I'd like to invite Mr. Yoshihiko Kataoka, General Manager for SRZ Promotion, Nuclear Segment, Mitsubishi Heavy Industries. Mr. Kataoka, the floor is yours. Good afternoon, ladies and gentlemen, and thank you very much for the kind introduction. This is Yoshihiko Kataoka from Mitsubishi Heavy Industries. I'd like to report on the initiatives for the development of next-generation advanced LWR at Mitsubishi Heavy Industries. First, I'd like to introduce our nuclear energy business. We are a general and comprehensive plant manufacturer. So we have been supporting LWR restarts, maintenance, and exports, fuel fabrication, supply, fuel cycle, and development of innovative reactors such as the SRZ 1200, as well as small light water reactors, fast reactors, high-temperature gas reactors, and nuclear fusion reactors. And so this is our SRZ 1200. That's the innovative advanced LWR. So from the design stage, we have embedded safety measures, and we are also using state-of-the-art technologies so as to realize the highest level of safety. The SRZ 1200's concept is as shown on the right-hand side. It is super safe and eco-friendly, and can supply in a stable manner very large amount of power. The SRZ stands for the different words that are listed in the bottom of the slide. And so where are we with regard to the development? For the SRZ 1200, we are working in tandem with 4 utilities that own and operate PWRs. So we are working on the standard plant development, and the basic design for that is almost finished. And we are also conducting various demonstration tests that will be fed into the licensing process. And things are going as planned so far. And we would like to improve the regulatory foreseeability. So we are actually working with the NRA and at the working level. We've already held 7 such sessions, and the results will be reported at the Nuclear Regulation Agency's commissioners meeting by the end of this financial year. So we are now ready to actually move into the detailed design for each and every siting. So this is about the standard plant and the basic design. So we have established the basic common specifications. We've designed the major components and the systems and the layout. So those are all almost complete. And then about the demonstration tests, this is just one example. So for the SRZ 1200, there are core internals, and they have a very new design. As you can see on the right-hand side, we have this setup for the demonstration test, and we are conducting the in-core flow test and collecting various data for the validation of the design. Now, with regard to the communication with the regulator that I referred to earlier, so these are obviously using some different design from the existing light water reactors. So some parts may not have the enough regulatory foreseeability. We have identified 3 potential issues, and we, as the licensees, have been presenting them to seek the view of the regulators. And we've been doing this for about a year, and by the end of this financial year, those results will be reported to the commissioners' meeting, as I mentioned earlier. Now, this is about our small light water reactor that we are also developing. Given that there will be various and different needs for the power generation, we are proceeding with the conceptual design using the Japanese technology for a small light water reactor. So given that it is a small reactor, we are using passive safety systems, and we are trying to make it that the seawater system is no longer necessary as a safety system that will allow for more freedom of siting. We will obviously address the seismic requirements, severe accident requirements that are required in Japan. Now, this is about building up the company's capacity to realize all that. Given that the government intends to maximally use nuclear energy, we are also building up our organization and the resources as well. In FY 2025, including the group and affiliated companies, we have hired 200 new people for nuclear related operations, and we will continue this in the next financial year as well. With regard to the training system we have in the company for construction, design, and maintenance, we have the fundamental courses, about 50 of them, covering all those different fields. And for the field skills, we are using simulators, virtual realities. We have various materials and modules ready. We also have programs for skills training, and so we have continued trying to offer opportunities for learning and trainings for our human resources pool. Now, with regard to the industrial base, the nuclear supply chain, as you can see, is like the lower left-hand side schematic, so it really has a broad base. And very high level of technology is already available in Japan, and that is used for the safe and stable operation of existing reactors. We obviously need to maintain that for the newer and more advanced reactors. So we are visiting our business partners. We host exchange meetings to have a shared understanding of the outlook and situation of the nuclear industry so that the overall community will continue to work together. And with regard to the construction of SRD 1200, we have been discussing with more than 200 business partners with regard to where we can work together. So we are working together with all those business partners and the community so that we can address the need or the demand for new builds and replace associated with the new generation reactors so that we can support the overall industry. Thank you very much.
Thank you, Mr. Kataoka. Not just design, but human resources development and industry-based enhancement through collaboration with partners, having meetings with partner companies were also mentioned. Now I'd like to invite Masayoshi Matsuura, Senior Engineer at Hitachi G. Vernova Nuclear Energy. Thank you. I'd like to talk about what we are doing to realize small, innovative LWR, BWR X300. First, the development strategy. The environment is expected to change in the future, and also in light of the geopolitical issues facing us, we are taking a step-by-step approach. First half of this century is shown on the top half. The light water reactors to contribute to the carbon neutral and highly innovative ABWR is to expand into the future. And through international collaboration, we are trying to develop the small-scale innovative reactors, BWR X300. By having those, we can do the decommissioning and building of the reactors in parallel within the same site. So we are trying to provide as many options as possible. And in terms of working together with renewable energy, we are to use the technology for load following and hydrogen production, as well as heat production. This is the larger one, HIABWR, which is based on ABWR. Lessons learned from Fukushima are being incorporated from the design phase so as to satisfy all the regulatory requirements in UK and Europe. And there are various safety features. One is the walk-away safe concept. As you can see on the right-hand side, at the time of accident, without the manual operation, the system could be run for 24 hours. And in terms of controlling the radioactive materials release, we use the noble gas membrane. Cesium is to be removed through the filtered vents, but also by removing the noble gas, the radiation level could be reduced to 1/100th, which would alleviate the need for the resident evacuation. And we're also enhancing the resistance to terrorist attacks and hazards. From here, I'd like to talk about the small reactors, BWR X300, for smarter, simpler solutions. Accumulating all of the expertise we have acquired over the last 60 years of BWR, 300,000 class is the output. Characteristics. Safety, the world's best safety is to be maintained and yet excel in economy, constructability, and flexibility. You can see the reactor building at the center. And what's shown in blue, that's the pressure vessel. And it supports the natural recirculation. And this is almost buried, and therefore it can resist attacks from outside, including the aircraft crashes. And we do have the integrated isolation valve. So by just shutting down the valves, we can maintain the coolability. And the natural circulation is used for cooling. For 7 days, cooling could be maintained without the operator involvement. By introducing these innovative technologies, we can reduce the amount of work necessary as well as materials. We have accumulated our expertise in modular building construction. We are trying to apply this broader for a assured and short-term construction. In terms of flexibility, of course, it will have a load following feature, an EPZ, Emergency Planning Zone. The planned zone for evacuation would be limited to within the premise so as to minimize the impact to the local residents. And we're trying to enhance the acceptability by that. And as the first country in the West to decide on this adoption, Canada raised hand. This is in the state of Ontario at Darlington site. 2030 is the scheduled date of the start of operation. Altogether, we're thinking of building 4 units. And this is the site as it looks today. I'm going to skip it in the interest of time. So the projects that are proceeding globally on the upper left, this is the Canada Darlington site, the right-hand side. And in Saskatchewan state, 4 more are to be built. And in the U.S., TVA is to build the site at Clinch River. The application has been submitted to have the construction permit screening to start. And in Poland, there are plans to build 10 units altogether. And there is a project going in UK as well. So GE Vernova Hitachi and owners are signing contracts to proceed this. And Hitachi GE Vernova is participating as the co-developer. So we're using the proven technology for early realization of the technology. As for fuel supplies, we are using the state-of-the-art advanced fuel on the market. And as for most of the systems and equipment, and the core internals and pressure vessels, we are basing on the existing technologies that are proven. And key is that from Japan, these components are to be supplied. That's the key characteristic of our approach. And as for the global deployment, as for main equipment to make a supply, we are collaborating. We are planning to collaborate with approximately 70 companies in the Japanese supply chain. We want to create business opportunities together with these Japanese partners so as to improve on the profitability as well as enhance the technology and human resources. And by collaborating with them for supply, we can ensure the success of the initial unit as well as to translate that into the mass production of the ensuing units. With regards to the technology transfer and human resources development, we are seeing the number of veteran experienced workers declining. So we want to increase the experienced workers by 50% by 2030 compared to today. And so we are taking various approaches addressing different aspects. That concludes my presentation. Thank you for your attention.
松浦様。Thank you very much, Mr. Matsuda. So BWX300 project that's going around the world, and it was quite impressive that Japanese businesses are also involved in the supply chain. So next, we want to invite Mr. Keiji Matsunaga from Toshiba. I am from Toshiba Energy Systems, and I'm the Chief Nuclear Engineer at Toshiba Energy Systems and Solutions. I'm Matsunaga. So today I want to talk about Toshiba Energy's efforts in developing innovative light water reactor, IBR. This is what I cover today. And let me first go through our structure organization. So Toshiba, underneath Toshiba, we have an operating business called Toshiba Energy Systems. So it's spin off. But this coming April, this Toshiba Energy Systems is going to be integrated back into Toshiba. So then we will be working as one operating department under Toshiba beyond April. Then also Power System Division, we had nuclear power, thermal power, and hydropower, but now we will be formed as a nuclear business department division from April onward. So we focus on the nuclear within our division. And next, let me talk about our efforts in nuclear power, starting from the front end on the left all the way through plant construction, restarting, decommissioning, or in the back end for the processing, retreatment, reprocessing. We cover a wide range of different nuclear business using different nuclear energies. We are also trying to contribute to new technologies as well. So let me talk about the safety which is pursued by this IBR. So this is what we are working on right now. So this is a lineup of this new reactor. So innovative light water reactor, IBR. In addition, we are looking at the high temperature gas furnace and a super small Muvlu X as well. And these are also developed. But today I will just focus on IBR in my presentation. So the safety pursued by IBR. As you can see in the left top, so at Fukushima Daiichi nuclear power plant, we learned lessons, so we need to make sure to address them. And we lost all the AC power. We experienced severe accident and meltdown at core, and a long-term evacuation forced on the local residents. So we need to avoid them as much as possible. Then, since the accident, there's been some changes in the regulation in Japan and around the world. In Japan, the new regulation is introduced to address the severe accidents and terrorism. And around the world, so they're talking about the period without operators to be shortened. Also, the target area for emergency planning to be minimized as much as possible. That's why to accomplish them, we need to accomplish with IBR with 3 points. So first point is ensuring up to 7 days of operator-free operation, even during severe accident, including prolonged total AC power loss. Second point, public exposure doses are suppressed even during core meltdown accidents. So emergency evacuation should be avoided as much as possible, and we want to cover that from design. The third point, and enhanced robustness of buildings protecting plant safety equipment. So to be resistant to very strict and natural environment condition, or the large aircraft impacts are also assumed. And this is the equipment to accomplish those points I mentioned earlier. And these are the main feature. And left top, this is about aircraft impact protection roof. So even with the aircraft impact, then we can protect the safety equipment. And to the right, a static reactor cooling system, static containment cooling system. And I will have more details on this point next slide. Then going down, core catcher and melt-through valve. Also to the left, double-walled cylindrical containment vessels. And we also have a static filter system for containment vessel. And those equipments utilized to accomplish those 3 safety-related elements I mentioned. And this is the safety system activation mechanism for IBR. So for some reason, core temperature increase because of the cooling suspension. Then, as you see at the right bottom, right top, static reactor cooling system, and that's what we use to remove the heat. The orange line, so hot steam will be released to the upper pool to be cooled down, and using the blue line to put the water back into the reactor so that we can continue cooling down the reactor. Then we should be able to contain any accidents to some level. But even though if we face the meltdown in core, the right bottom, left bottom, we have a core catcher, so we can receive the melted core, and once we receive at the bottom, and then we can also circulate water from the bottom side as well, so we can continue cooling. Then we continue cooling, then the water will be actually evaporate along with the hot heat. Then to remove the heat, then we use the left top. This is the static container cooling system. That's what we have. Then, and just like earlier again, same mechanism. The orange line, we take the hot steam to the top and cool down at the top. Then once they cool down, then put them back into the suppression pool at the bottom. So at the same time, radioactive substances and also some gases will be created. Then we use this green line to go down to static filter system. It's a filter vent, just like filter vent, and then we remove the basically radioactive substances, like including hydrogen. Then and we will actually contain them into the double cylindrical or containment system, make sure that they will not be released outside. Next, talking about the robustness of the building. We're using the steel concrete structures, steel reinforced concrete structures. So instead of having concrete or surrounding the steel reinforced, but inside this steel plates we pour the concrete. Then the right-hand side is showing the examples of testing and analysis. So this, in case of the steel plate concrete, even with the impact of aircraft on the backside will not be separated, so it will not be broken. So we confirm through the testing. Then safety category, ABWR, this is already applied safety category, and we are reinforcing these categories furthermore. On ABWR, we have 3 categories, safety categories. In addition to these 3 categories, we are also adding the countermeasure for severe accident and SSA equipment, severe accident equipment. So we have very tight categorization to be applied. And SA equipment, severe accident equipment, and also along with the DB equipment, we will have both static and dynamic safety systems. And so we can actually distribute also diversity to be ensured. And we also will have a high load following capability as ABWR. We will coordinate with the renewable energy, coexist with renewable energy. On ABWR, there is a flow limitation using the recirculation pump, and we will basically apply the same concept into this plant. And let me talk about where we are at right now. Development schedule. This is the schedule we are moving on right now. At the very top line, the METI subsidy project. So this is we are working on development with the subsidy. Basic designing, analysis, confirmation, testing are conducted here. Middle part, this is the Japan Atomic Energy Society action. Then bottom is the regulation authorities, technical discussion with them. And we are participating in this discussion as well to confirm the current status. And this is the development status. And these are the testing we are working on right now. Especially analysis code verification is here. And compared to ABWR with IBR, after the accident, the pressure is actually minimized and compared to ABWR. That was confirmed. This is activities taking place at the Atomic Energy Society of Japan, AESJ. So the nuclear, so AESJ has already put together the needed technical requirements, and they are reviewed right now for the next, reactor. So for 2024, they have went through the discussion for about a year. At the end of last year, they put together a summary to come up with a report at the right bottom that was already issued. So with the accident at 1F Fukushima, based on what happened on BWR, there are kind of actions to consider BWR specific design, and that is incorporated in the next generation version. And the concept for next BWR is also meeting the requirements put together through phase 2, and they also confirmed no new additional issues, and that was put together in the report. And we also want to utilize this information into our reactor. Let me also touch on the human resource development and supply chain maintenance. So human resource development. This is our program to develop human resources. To the left, in the middle, where it says technological training, that is actually consisting of 4 major pillars on the right-hand side in orange. Safety training is the basis, and nuclear engineer education, and monozukuri, the manufacturing education, and the global education. Especially this manufacturing-related education, even trying the shutdown, reactor shutdown, we have been conducting training on the field. So simulation and site training, hands-on training were all combined together to be was offered. As the engineer training, we are focused on also younger people and the new members, and so to give them the basic training and the specialized education to them. And supply chain situation. We have identified issues in supply chain, as mentioned also by the previous presenters. Then as a counter actions, we want to create more opportunities for training using subsidies, and we want to propose more highly dependable maintenance plan, and also activity for outreach activities. And I think this is also another important opportunity to have better understanding by the suppliers. But still, there is a risk of withdrawal of suppliers, and those are cases the supplier decided to withdraw. So we need to find alternative suppliers, and we can further use the general purpose product, industrial products available in the market as much as possible. And this is one example on the left. This is something that we work with a material supplier to come up with a new core material. We are working on this. In the middle is using 3D printer. This is a new technology, a manufacturing technology we are trying to establish using 3D printer. The right-hand side is outreach activity, so we participate in international, conferences and exhibitions. And summary. So through these efforts, we take the lessons from Fukushima accident, and we try to build an innovative IBR to meet all the requirements set globally. And so we hope to accomplish this as early as possible. This concludes my explanation. Thank you.
Thank you very much, Mr. Matsunaga. Thank you very much for sharing with us the details of IBR. I'd now like to invite Mr. Daisuke Koichike from IHI and Mr. Masahiro Yanagisawa from JGC, and they will share with us about their NuScale project. Good afternoon, and thank you very much for your kind introduction. This is Koike from IHI. I would like to talk about the NuScale SMR business and the project that we are working together with JGC, and therefore the presentation will also be delivered jointly. First, let me provide a brief overview of NuScale SMR. This shows the plant layout and the building structure, and the right-hand side shows the reactor module, which is the core part. In the large reactor, we had the RPV and SG containment vessel. They were all separate, but they are actually integrated in one single module. And this module will be installed in the reactor building and inside the pools, and actually a total of 12 of such modules can be placed in one building. So SMR is an integral type of PWR, and so we can leverage our expertise in the LWR. And you can have a total of 12 modules maximum, but it can really depend on the user needs. So we have standardized modules, 4 module, 6 module, 12 module designs. And this shows the innovative design. So the reactor module is integrated, and therefore we don't have to work about large loca. And we are using a passive safety system, and we're also using natural circulation, so that even in accident situation, we don't need to worry about off-site power or pump for primary coolants. And we also have the containment vessel that can withstand very high pressure. That's the new design, so as to minimize the release or non-condensable gas. And we also have the ultimate heat sink inside the building. This is Yanagisawa from JGC. I'd like to talk about what we're doing and the energy policies in Japan and the world that provides a context for the SMR. So as we heard earlier from the agency, there are SMR projects in the Western world, but even in Southeast Asia, the first program, or AZEC, the Asia Zero Emission Communities, there are projects that are supported by the government of Japan and the United States to build nuclear in the Southeast Asia, and we are part of that. And then in Japan, as we all know, the 7th Strategic Energy Plan and the GX 2040 vision actually refers to small reactors, not just light water reactors. So, and it's also talked about Japanese companies being part of international projects. So we are also trying to be part of that. Now, specifically with regard to new-scale SMR in Japan and United States and Europe, TVA is looking for a maximum of 6 gigawatts. And then in Romania, we've also signed FEED. We completed the phase 1 for FEED, and we also have the final decision made for FEED phase 2, and going to pre-EPC. And then for Southeast Asia and Africa, there are various support and assistance programs, and we are also active here. Particularly, we're working on Indonesia, and we were involved in the feasibility study there. So with regard to this feasibility study, with the support of the United States government, that was conducted in 2023-2024. And as was referred to in the agency presentation, in Indonesia in 2025, they have presented a very specific nuclear energy program. And in the West Kalimantan, that's one candidate for a site for new-scale SMR. We are working with a U.S. company to continue with sounding that possibility. And with regard to technology development and supply chain enhancement in conjunction with the new-scale SMR project, we are actually working with the subsidy program from METI and the agency, and particularly with new-scale SMR, we are looking at the delta, the difference from the U.S. standards when we are bringing this to Japan or Southeast Asia, and we are looking at that difference and the necessary R&D, and we are also working on the construction method. And we would like to thank the supply chain partners that we're working with. And we're also working on the regulatory framework and some research. In Japan and the United States, there are established regulatory systems, which is not the case in other countries in Southeast Asia. So we are looking at the existing regulatory frameworks and what that could mean for the supply chain when we go to the other countries. And then on slightly different tone, the SMR business is a little different from the large nuclear power station business. That's our idea. For example, with regard to NuScale, if you look at the right-hand side and the purple part, that's the reactor or the core part of the nuclear power plant, and that is provided by NuScale. But the other parts like EPC, construction, etc., procurement, those would be done by the EPC contractor. So that's different from before. So for us, we could actually work on as an APC, and so we can actually be responsible for everything other than reactor, but that would require the cooperation from other suppliers. We are actually working on a government-funded project to look at the human resources exchange, particularly with the Global South, and looking at how nuclear energy can be introduced in other countries. So we look at various components and where the Japanese companies could actually be part. As of last month, if you could look at the right-hand side, for the major components, we actually conducted a survey among the suppliers in Japan, and you can see the number of companies who are actually specifically interested in being part of specific international projects. In the past, if we think about nuclear power station buildings, the part of the safety related systems were very tough requirements. But for smaller stations, we can apply a graded approach, and not everything is so rigorously required, and it's not just regulatory requirements, but we can also utilize commercial grade items. So some of the companies that showed or indicated interest in this table, obviously, most of them have already supplied to nuclear power stations, but we also have other companies that are thinking about entry into this field. Now it's back to IHI. I'd like to talk about what we're doing. So in Romania, we have this project called Doicești. And we've completed phase 2 of the FEED, and we are trying to realize the commissioning in the early 2030s. So we've looked at the containment vessel and the steel module that will form the reactor building. And we are working with local companies, looking at what procurement model would be best, and we are trying to reflect that into the project planning. With regards to large components and enhancing the seismic performance, in the NuScale module, we are using special materials, but we actually have established the welding technology, and we are doing a final validation. So we are conducting a mock-up, full-scale mock-up test. And the NuScale SMR is actually designed as a standard. The standard design is US-based, and we are also looking at how we can adapt that to more seismic-prone areas such as Japan and Southeast Asia. And what IHI is doing to grow our nuclear business, and this is actually from our earnings briefing, but our strength is that we cover the whole process from the front end to the back end. And so we would like to continue to contribute to the nuclear industry home and abroad. And for the medium and long term, we would continue to provide major and key components to various sizes of reactors and systems. So necessary CapEx, capacity expansion, technology development would also be part of our focus. With regard to supply chain enhancement and human resources development, for this real-scale project for new-scale SMR, we are trying to supply the right components and services, and we are working with the domestic suppliers and building prototypes, etc. So we hope that through those opportunities, that should support the human resources development at the suppliers as well. And we're also trying to help develop the human resources that work in the manufacturing fronts, necessary expertise, skills. We would like to make sure that there's a right human resources pool. We would also focus on training and education. And that will involve nuclear safety and quality, or reducing the risks thereof. Last but not least, currently we are focusing on the projects that are going on in the Western world for the specific design, but we are also working on the design that would be relevant for Japan and other countries over here on this side of the Pacific, with some support from the government. And over the longer term, we would also like to involve more suppliers in actual building and validation. Thank you very much.
Thank you very much. SMR projects overseas were described in detail. Thank you very much. We are running out of time, but we now like to move on to the presentation by Holtec and Mitsubishi Electric. From Holtec, Haizen Pan and Soichi Hamamoto from Mitsubishi Electric will be making presentation. First, we have a video message from Holtec. It will be in English. So if you wish to listen in Japanese, turn to the Japanese channel.
I'm the corporate director of Holtec International. It is my great pleasure to introduce you Holtec and our SMR program. Holtec is an innovative technology company. We are vertically integrated in design, manufacturing, construction, and commission. We are a very stable partner, which is important when entering into a project like a new nuclear. We are one of the biggest nuclear capital equipment manufacturers in US and own manufacturing technology and international acclaimed QA program. This is our business portfolio. We're a nuclear company providing broad products and services. We cover almost the entire life of the nuclear power plant. Important, we committed to deliver a Fukushima-proof SMR to solve the energy crisis. We are the world's leader in providing spent nuclear fuel and red waste management solution. We have over 70% domestic and 60% international market due to our technology excellency. As you can see, we have over 2,300 dry storage systems loaded on 153 nuclear sites. We are also the largest commercial nuclear power plant decommissioning company in US. We are the licensing of 5 decommissioning sites and currently performing fleet decommissioning work on all these sites. We established and implemented advanced decommissioning technologies with improved safety and efficiency, which is essential to the implementation of nuclear as clean energy. We acquired the Palisades in 2022 for decommissioning, while under the support from the state and federal government, Holtec is executing the first ever restart of a shuttered U.S. nuclear power plant, marking a historic milestone for the industry. Holtec plan to also co-locate a dual unit SMR plants by 2031, which demonstrate Holtec's unique ability to bridge legacy and next-gen nuclear. Here are the key attributes of our SMR300 technology. Simplified PWR reactor with a proven technology platform and dramatically reduce the number of systems and equipment. Use of off-the-shelf proven technology significantly reduce regulatory risk and provides commercial certainty. Small in size, compact reactor core with high output. Modular structures, maximize automation and off-site fabrication and supports efficient construction. Passive safety, walk-away safe with no immediate action required. 40% of staff required compared with traditional operation plants. Our SMR300 also stands out when compared to other light water reactor SMRs on economic by scale, size, and area comparison. It is further differentiated by an air-cooled condenser cooling option and UMAX spent fuel storage facility as turnkey fuel management solution through the life of the plant. As stated above, Holtec will build, own, and operate the FOK dual unit SMR300 plants at its Palisades site with the capacity of 600 megawatts and a commercial operation date of 2031 and 2032. The licensing path for Palisades SMR300, our completed key milestone is submitted construction permit application part 1 in 2025. Currently working with NRC to target a 12-month review and keeps us on track to begin pre-construction activity in 2027. Subsequently, CPA Part 2 and Operation License Application submittal follow through 2027 and 2030. This is the construction plan for Palisades SMR300, targeting completion of Unit 1 by 2030. Pre-construction activity began in 2026, leading the first nuclear concrete in early 2028. The critical path shown in red ensures that all construction activities stay tightly sequenced to support our Mission 2030 goal. This is our overall delivery structure. At the top is the project SPV. Palisades Energy LLC serves as the operator, and Holtec Hyundai jointly lead the EPC. This is one-stop shop model can be applied to any nth-kind SMR300 project worldwide. As we look ahead, Holtec is committed to building a global high-quality supply chain for the SMR300. Japan remains our most important partners. In particular, Mitsubishi Electric plays a critical role in our program, providing world-class instrumentation and control systems that are essential to the safe and reliable operation of our reactors. We believe Japan's capability will play an essential role in its global deployment. We look forward to working together to shape the future of clean energy. Thank you. Have a good day.
はい、ありがとうございました。続きまして、
Thank you. We now give the floor to Hamamoto-san from Mitsubishi Electric.
はい、それでは続きま
Thank you for the kind introduction. I'm Hamamoto from Energy Systems Business at Mitsubishi Electric. I'd like to talk about the nuclear power business of our company and our collaboration with Holtec on SMR300. First, brief introduction of the company. and the history of our nuclear power business. Our management structure consists of 3 business areas, namely infrastructure, industry mobility, and life. Nuclear power business belongs to the Energy Systems Business Division within the infrastructure business area. Starting with the domestic production of nuclear power generation technology, we have since expanded our business both in Japan and overseas. With a view to continuously maintaining, retaining, and strengthening our human resources, technical capabilities, and supply chain into the future, we are currently steadily responding to facility renewal work in Japan and working on the joint development of SMRs, as has been explained. Next, I would like to talk about our initiatives towards SMR 300 realization. We have been involved in Holtec's development projects since 2016 and have been responsible for the development of instrumentation and control devices for 10 years. SMR 300 will be introduced in the U.S. and then expanded globally, with development being promoted in collaboration with multiple companies. With 2 key priorities, that is, complying with global regulations and standards and collaborating with leading companies in each field, we are working to obtain licenses and permits, strengthen OT security, and build a supply chain. And you can see the details starting with the next slides.
原子力発電所向け安全係争制御プラットフォームメルタックでございます。原子力で特に重要度が高まる
First, we introduced MELTEC, a safety instrumented system control platform for nuclear power plants. It features separate and independent design and high seismic resistance, which are particularly critical in nuclear power, providing digital platform that operates reliably even during emergencies. We have strengthened compliance with global regulation, including EMC, to apply MELTEC to the SMRs 300. As a result of these technical efforts, we have obtained approval from the U.S. Nuclear Regulatory Commission for its application in safety systems. Second is a commitment to nuclear power plant security. In the increasingly critical field of security, we are advancing the provision of IT/OT security solutions, including OT security that protects equipment, such as control systems that automatically manage nuclear facilities from cyber attacks. Leveraging the technology of Nozomi Networks, a subsidiary possessing top-tier OT security expertise, and integrating it with our own technologies, we aim to deliver security solutions that meet stringent overseas regulatory requirements. Third, we will introduce the development of nuclear instrumentation systems in collaboration with leading companies in each technical field. Nuclear instrumentation systems are critical equipment for measuring nuclear reactions inside reactors, and our company is one of the world-leading vendors of such systems. In cooperation with Kyoto University, we are working to commercialize self-powered neutron detectors, SPND, a cutting-edge technology not yet introduced in Japan. We are strengthening our supply chain both domestically and internationally, including the development of such core technologies. Finally, to address robust electricity demand while advancing towards a decarbonized society, we are committed to further contributing to the safety and stable power supply of nuclear power generation through initiatives such as those introduced. Thank you for your attention.
ありがとうございました。
Thank you very much. This concludes the presentations for this session. And I'd like to make a concluding remarks. The presentation talked about 2030s in many instances. I think the key word is 2030. This year is 2026, and towards the 2030s, the projects are proceeding in a very concrete manner, as has been presented. To enhance supply chain, new projects, new business opportunities would be a very important factor. On the part of the government, we would make efforts so that concrete projects could be realized. And on the part of the private sector, I encourage you to take up new challenges as well as collaborate towards the 2030s. And with that, we conclude this session. Once again, I'd like to thank all the presenters. Thank you very much.
宮下様、パネリストの皆様。
Thank you, Miyashita-san, and all the panel members. Please join me in thanking Miyashita-san, the moderator, and the panel members as they return to their respective seats. Thank you. We will now take a 15-minute break until 3:10. In room A, coffee and other beverages are served. The aisle on the right-hand side is available as well.
また、以降のセッションはすべて
The rest of the sessions will be in Japanese, so simultaneous interpretation would only be from Japanese to English. Those of you who would no longer be needing the receivers for the simultaneous interpretation services, we ask you to kindly return your receivers outside. And this is the announcement for the online participants. This will be a 15-minute break. We'll resume at 3:10.